Hey, thanks for joining me. I'm Nick Miller, and welcome to Rigging for Production with Maya and Python. In this course, we will cover the basic elements of rigging and Python scripting in Maya. We will start by learning about commonly used nodes, deformers, constraints, and other types of relationships within the program. We'll then learn how we can apply these concepts to more complex rigging systems. When I demonstrate how to manually build something in Maya, I will also demonstrate step by step how to achieve the same results through automation with Python. Automating different rigging setups is an essential part of the production pipeline at any major studio. It allows a rigger to very quickly build and maintain animation-ready assets. When the process of building rigs is scripted, it becomes much easier to update your rig with a new model, additional functionality, or a different joint layout. If most companies already have rigging setup tools, why do I even need to learn scripting? To an extent, you can get by without scripting, that's true. However, studio tools can only get you so far. There will still be many instances where you'll need to automate a repetitive task. Imagine having to manually rig 100 pieces of variously sized ropes dangling from a ceiling. It would take a long time. Scripting enhances your own personal workflow and makes you infinitely more productive, thus giving you an edge over the competition. Also, it's not uncommon for a tool to return an error message. You'll want to be prepared for some troubleshooting if something like that were to occur. Speaking as somebody who did not enter the visual effects industry with a background in computer science, I know that the thought of writing code can be a little daunting. Let me assure you, there's no need to worry. This tutorial is intended for beginners who have never done any rigging or scripting. Together, we'll go through some of the steps I took to get from knowing absolutely no scripting whatsoever to somebody who uses Python on a daily basis. At the end of this course, in addition to all the helper scripts that we write together, you will have written a Python limrig creator with a simple GUI. Lim functionality will include IK-FK switching, a full set of basic lim controls, and stretchy bones. Alright, let's get started. Hey, what's up everyone? Thanks for joining me today to learn about some of the foundational elements of rigging. It's important to mention that what we cover in this lesson is not exclusive to rigging. We can apply these concepts to any discipline in Maya. Let's start by taking a quick peek at what happens under the hood of the program as we populate our scene with objects from the Create menu. Before we do that though, I want to introduce the Node Editor, which you can find under Windows and then Node Editor. I'll go ahead and dock this on the right here. A rig, or any Maya scene, is comprised of these little objects called nodes. But what are they? They are essentially containers of data that flow from one to another to represent a larger picture system. For example, let's take a look at what happens when you create a sphere. I'm going to go to Create, Polygon Primitives, Sphere. You'll notice that 3 nodes appear in the Node Editor. These nodes represent the sphere that we see here in Maya's viewport. Let's talk a little bit about what each of these does. This node here, Polysphere 1, is the creation node, and it contains information about how the sphere was built. This type of node can also be referred to as construction history, and we can see different parameters if we look in the attribute editor about how the sphere was built. We can also see them in the channel box. If I select, I can select the sphere in the viewport here and see the different inputs. This one, Polysphere 1, are those same parameters that we just saw. And if I change them, you can see in the viewport the sphere is changing size and shape interactively. You can also see these parameters when you go to build the sphere. If you go to Create Polygon Primitive and click this square icon here, known as the option box. Here are the different parameters for the sphere. This node here, pSphere 1, is the transform node, and you can kind of think of this as a container for the polysphere shape. This node records how the object as a whole, as one unit, travels through space using translate, rotate, and scale. And you can see as I move the object with the manipulator in the viewport, I just set a key, I didn't mean to do that, but you can see like all these keyframe nodes appear in the node editor. When I accidentally hit S. I'm going to undo that though. But you can see the transform values are being displayed here, and this is happening on an object level and not the different components that make up the shape, which we'll get into next. pSphere shape 1 is the shape node. This contains all the point information about your object. Since a shape is essentially a collection of points, all the point positional data is stored here. Other things like how the object is displayed or rendered is also stored in the shape node. You can manipulate the shape and transform inside of Maya's viewport directly by using different selection modes. In object mode, which we're currently in, you can access the transform node, moving the sphere as one unit, just like we did before. If I go up here and expand this, you can see the different object types that you can select in the viewport. Turning one off, like surface objects, I can no longer select polygon meshes in the viewport. I'll have to turn that back on if I want to select it again. If I go to component mode here, or press F8, I'm granted access to the different components that make up a shape. I have my vertices. You can see I have access to edges and faces. Those are all here as well. You can also see if I select these vertex components and go into the channel box, I can see those values for where those points are stored. Keep in mind this is not the same as the transform, moving it. So we're actually moving the points that make up the shape, not the transform. So keep that in mind as we move forward and start to manipulate our shapes and our transforms. I like to think of object mode as the transform node and component mode as the shape node. I also want to mention that I keep my outliner open almost all the time. I think it gives you a really good description of what is in your scene and all the different hierarchies that you have. Right now, we only have a sphere. But if you notice, this pSphere 1, that's the name of the transform node and not the mesh, pSphere shape 1. But we happen to see this icon. That's actually just a functionality of the display in the outliner. If we wanted to see the shape in our outliner, we could turn that display on. And now we can see the two here. I usually leave that off. That's just a personal preference. But it's good to know that you can see them both in the outliner as well. In the next section, we'll take a look at how to create some new nodes and start connecting them together. Now that we know what a node is, let's talk a little bit about the different types of relationships that nodes can have with one another. Since we have the node editor open right now, let's talk about direct connections first. These lines represent direct connections. They can be used to transfer complex shape data, simple transforms, or just about any attribute you can imagine from one node to the next. If you select these nodes and press 2, you can see what's actually connected. Here we have the output of polysphere 1 connecting into the in-mesh of pSphere shape 1. In essence, what that means is that this node is creating the polymesh that we see here. If I press 1, I can collapse these nodes into a more simplified view. Press 2 again, see what's connected. And if I press 3, I'll get a larger list of attributes. If I press 4, nothing's going to happen yet because that would display custom attributes, and we haven't defined them yet. So we'll get into that a little bit later, but for now, I'm just going to collapse these. Once you're satisfied with how your shape is created, it's okay to get rid of this construction history node. It just makes your scene a little bit more clean, and it won't conflict with any other inputs that you might want to feed your shape later on down the road. One way to do that is select your object and go Edit, Delete by Type, History. There, now that's a little bit more clean and I already feel better. Let's try creating a locator node and use it to drive the sphere's transform. Locators are basically points in space with a shape attached to them so we can see it in the viewport. If I go Create, Locator, I now see I have these two nodes, a locator transform, and a locator shape node in my node editor. I don't see it in the viewport because it's actually obstructed by the sphere. The locator shape node has a local scale attribute that I'm going to set to 2, and now I'm able to see it. Just keep in mind that's the shape scale, not the transform scale. Right now, this locator and sphere are working independently of one another, but what I want to have happen is the locator, I want to drive the translates of the sphere. To do that, I'll come into my node editor, press 2, I can see that nothing is connected, so I'll press 3 to see the other attributes I have, and these look pretty much the same because they're both just transform nodes. And I'm going to have the locator connect it. Just select this dot to connect and drag it over to the sphere's translate, and it will make that connection. If I select the sphere, I can see that these channels are now yellow, and that represents the direct connection. So now I can move my locator and it moves the translates of the sphere. I'm going to turn wireframe on so I can show you that if I rotate this locator, nothing happens. If I want the sphere to rotate with the locator, I'm going to have to connect that as well. There we go. Now the sphere controls the translate and rotate of the sphere. Sorry, the locator controls it. If I scale the locator, nothing has happened. If I connect the scale, now it will scale that too. But if I select the locator shape and increase the local scale, nothing happens because this attribute just changes the shape of the locator. I'll make a new scene here, and we can do another example. If I go up here to the Create menu, go to Polygon Primitives, Cylinder, we'll click on the option box, and I want the cylinder to face down the Z-axis, so I'll set that here. Click Create. Let's take a look at it in the orthographic front view, and maybe we'll make this a little bit bigger. So if I go to the construction history, you can actually just set the radius to 3. And I also want this to sit on the ground plane, so I'm going to raise it up by 3 units in Y. I'm also going to turn on wireframe on shaded. What we're going to learn is the basic principle of a tire roll. So we can imagine the cylinder is a tire. Just like before, I'm going to create a locator to drive the transforms of our object. If I press and hold the V key, I can snap this to the center of the cylinder, and we want to be able to see it, so let's change the local scale to something larger than our cylinder. Great. And let's hook up the translate again. So now our cylinder should come with our locator when we move it. But we want this to roll across the ground. So how do we get it to do that? As it just so happens, I remember from junior high math that the circumference of a circle is 2 times pi times the radius. So if I whip out my handy dandy calculator here and do 2 times 3.1415, round down for pi, times 3, which is our radius, equals 18.849. So I'm just going to copy this to my clipboard because I'm going to use it in a second. So what I want to happen when I translate my locator 18.849 units, the cylinder should complete 1 full revolution. That's a rotation value of 360 degrees. So we go back to the calculator here. We want our multiplication factor to be 360 divided by this number. So we'll take 360 and divide it by 18.849. And we get this really long number. Let's just copy part of that and set that aside here. In order to calculate how much the wheel needs to spin, we're going to have to do some math inside the program. So let's start by going to the node pane here, and we're going to create some utility nodes to do the math. If we go here to multiply divide and click on that, we'll create a node. And if I expand this, I can see there's some input connections that we can use and an output. Let's go ahead and hide this node pane. And I'm going to rearrange my nodes just to make a little bit more sense of the way I want this to flow. So we're going to use the locator, do some math, and we're going to connect it back into the cylinder's rotate. Ultimately, we want to drive our roll with translate x from our locator. So let's expand the translate attribute, and I can go ahead and drag translate x into our first input of the multiply divide node. If I go ahead and click on that and open the attribute editor, I see the columns that I want to multiply from. We're only focusing on this first one for now, and I'm going to go ahead and paste the value from our calculator into input 2. This is our multiplication factor. And then I'm going to take the output x, and connect it into the rotate z of our cylinder. And you'll see you get this node. Don't worry about it for right now. I'll explain it in a little bit. Let's just make this a little bit more legible. Let's see what happens when we move our locator now. You can tell that the wheel is not spinning in the right direction. It's a pretty easy fix. We just have to negate our multiplication factor. Now if we take a look, it is rolling along the ground plane properly, as we would expect to see a wheel turn. Using a multiply divide node works, but it might actually be a little overkill for what we need it for. You notice here, we're not really taking advantage of these two columns, and we're only using the default function of multiply. Keep in mind, we could also use this to divide or raise to the power of. I'm going to suggest we use a more simplified node called mult double linear. If you know the name of the node, you can just press tab in the node editor and start typing it. So it's called mult double linear. And here we go. If I just use my down arrow key, or I could click on it, creates this node. And I'm going to connect my translate x. If I don't see an input here, I could expand, or I could just drag into this dot, and it will give me a list of attributes that I could connect it to. So go ahead and connect that. And I'm going to take the multiplication factor that I was using before and just paste that into input 2. Awesome. Now I can just connect this into rotate z. If I connect into something that already has a connection, it's just going to overwrite that connection. So we'll break what's there and create this one instead. That is great. And now if I go to my locator and move it, it's doing what it was doing before, which is exactly what we want. I provided 2 scenes along with this chapter. In the first one, it's nothing too fancy, just a couple of unrigged primitive gear shapes. Your goal is going to be to drive the rotation value of the last 3 gears using the first one, like I've done in this scene, which is the second file that I provided. I've also gone ahead and given you the radius of each gear to help you calculate the math. Take a moment to pause this video and open the first scene. See if you can get these results before I go over how I got there myself. Alright, hopefully you now have a setup similar to what I've done here. One thing that I love about rigging is that there are several different ways to get the same results. At the end of the day, as long as your rig performs well, you've done your job. I want to show you what I've done in the assignment solve scene, but let's start by going over 2 terms you'll hear me say all the time. That is driver and driven. The driving force in my scene is this first gear. My driven objects are these other 3 gears. To be more specific, C gear 01geo.rotate z is my driving attribute, and the driven attribute is the rotate z on these other 3 transforms. Let's dive into these nodes. I'm going to graph my network. Whenever I say I'm going to graph something, I usually mean that I want to display the connections between certain nodes. To do that, I usually use one of these three buttons in the node editor. As the tooltip here suggests, this button graphs input connections. This will graph both input and output, and this graphs just the output. If I graph the output connections of this big guy here, you can see that it's not connected to anything. It's not a driver. But if I go ahead and graph the input connections, I can see something is coming from C gear 01 geo all the way over into our second gear. Something is happening in between. Let's talk about that. What are these unit conversion nodes? You might have noticed that these nodes sometimes get automatically created when you make connections. This is Maya making sure that 1 unit of your output or source connection is equivalent to 1 unit of your destination or input connection. For example, this is converting units of degree into linear units, because we have rotate z connecting into our mult double linear node here. If I'm being completely honest, I tend to let Maya do its thing here and ignore these. Just know that they're there, and it's great that we rarely have to worry about this kind of conversion math inside the program. With nothing selected in the node editor, if I press 2, it will expand and show me the connection view on every node. Another way, instead of using our 1, 2, 3, 4 hotkeys, you can actually use these buttons as well. I know that this gear is twice the radius of my first gear and has twice as many notches or sides. So what needs to happen is when this gear completes one full revolution, the larger gear should only complete half of one. To represent that in the multiplication node that I've created here, I have my rotate z from my first gear connected into the first input of my multiply divide node. So if I go into the attribute editor, I just did Control A to open that up. You can see the connection here. And I also want to half that. I also want to reverse the direction. So I made it a negative number. So now, when this rotates 360 degrees, this should rotate negative 180 degrees. To clear everything in your graph, you can press this icon here. We'll go ahead and graph all of these together now. We see something very similar to what we were just looking at on the second gear, but now we can view them all at the same time actually. If I look at the mult double linear node on the third gear, I can see it's getting 2/3 of the rotational value. And if I look at the fourth one, it's getting negative 2/3, so it spins the opposite direction. I see some other nodes here that I don't really want in my node editor, and we can go ahead and get rid of them by selecting them all, and then hitting this remove nodes from graph icon. And there you have it, your first node network. Before we move on to the next chapter, I just want to introduce you to a handful of nodes that I find myself using all the time. I won't go into great detail right now, we'll be using these later in the course, but I do want to show you them so you can start to think about what's out there. These first two nodes I use for measurement. Distance between, as you can imagine, measures the distance between two objects. Curved info you can use to measure the length of a curve. Multiply divide and mult double linear we've already used and talked about some. Plus minus average is very similar to multiply divide in the sense you can change the operation to change its functionality. Add double linear is very similar to mult double linear. It's just adding two numbers together. We have condition nodes, and you can use these to compare two values using a first term and a second term. I often use this reverse node when switching between two states, because the output is 1 minus the input. So, in essence, 0 becomes 1 and 1 becomes 0. This last node here is a blend colors node. And yes, you can in fact use it to blend two colors together. However, I very rarely use this to actually blend color data. If I go into the channel box here, you can see there's a RGB value for color 1 and for color 2. When the blender value is set to 1, the first color is active. When it's set to 0, the second color is active. I like to put object's rotational or translation value here and use this blender to switch between the two. Sometimes I like to use this instead of constraints, which we're going to talk about constraints next. So let me show you some of those before we get into the next chapter. I really just wanted to show you what the different nodes look like in the node editor. Here you have your point constraint, your orient constraint, your parent constraint, scale, and aim. And we will go into detail on what each one of these does and how you use them in chapter 2. The node editor is one of the most powerful tools for rigging at your disposal. It allows you to visualize all the connections for any node in your scene. I almost always start here when debugging a broken rig. I will be using this tool throughout the series, and I highly encourage you to use it all the time as well. Thank you for joining me in this lesson, and I hope to catch you again in the next one.